Welcome to New Frontiers, a new show that's all about exploring science, discovery, and innovation that's happening right here at the University of Arizona. I'm your host, Erika Hamden. I'm a professor of astrophysics here at the UA, and I'm so excited to share these stories with you because they're all about the work that I love doing, discovering things about the universe, and then sharing those discoveries with everybody so they realize what an incredible world we live in. My own journey of discovery started when I was in first grade, when both of my parents, who are scientists, told me about things like the Big Bang and evolution, and they sent me on this track of learning how incredible the world and the universe actually is. And so since then, I've been following my dreams of becoming an astronomer and maybe becoming an astronaut. And I've always wanted to go to space, but I also feel like, well, if I can't go to space, at least something that I build can go to space. So that's why, as a professional astronomer, one of my favorite projects is a telescope called Fireball. Fireball is a telescope that flies on a high-altitude balloon and goes all the way to the stratosphere. It's designed to give us a better view of distant galaxies and how they form. And I've been busy working in my lab with my students to align and improve Fireball's instrument and get it ready for its next launch, which will hopefully be in September of 2023. One of the most satisfying parts of my job is working with my group here at the University of Arizona, which consists of undergrads, graduate students, and postdocs. It's an honor to me that I get to mentor this group of aspiring space explorers. I love teaching, and it's so satisfying to ignite the spark of curiosity in the next generation, the same that my parents did for me. I also think that accessibility to science is so important for our society. And so that's why I do my best to make science fun and interesting. In fact, I host an Instagram channel where I talk about all the weird things in space. The universe is almost 3 degrees Kelvin. You can survive in space without a spacesuit, but only for like 15 seconds. Mars actually is the winner for having the biggest, maybe coolest volcanoes. And it turns out there are a lot of weird things in space. Of course, I'm still pursuing my dreams of becoming an astronaut, which is one of the reasons why I'm studying to get my pilot's license. There is nothing that beats having a bird's eye view of the world in a plane that you are controlling. And I just really love learning about and exploring this wonderful world. And that's why I look forward to sharing with all of you the bold new frontiers of science that are happening right here in Southern Arizona. The U of A is one of the best universities in the country for studying science, and that's especially true for the space sciences. In fact, we're consistently ranked #1 for astronomy and astrophysics. I'm here in the shadow of the 100-year-old Stewart Observatory. I'm on my way to visit 2 of my incredible colleagues, George and Marcia Rieke. They're a husband and wife team who built not 1, but 2 of the instruments for the James Webb Space Telescope, NASA's largest, most ambitious telescope ever. Last year, we did a segment on the making of the James Webb Space Telescope. So check it out, and then meet me after in their office.
So the James Webb Telescope is the end of a series of infrared telescopes in space. It's much bigger than we've ever launched before into space. In fact, it's bigger and more sophisticated than any telescope, much less an infrared telescope.
Really what makes it special is that it's opening up a new wavelength regime, and so it's going to show us quite a new view of the infrared universe. One of our key goals is to find the first galaxies, so we'll be able to trace things a lot further back to the Big Bang than we have before. I'm Marcia Rieke, and I'm the team leader of one of the 4 instruments on the James Webb Space Telescope.
And I'm George Rieke, and I'm the co-lead on the second of the 4 instruments on James Webb.
T-6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
In the 1980s, there was a program that NASA ran called the Great Observatories. And the Hubble Space Telescope was part of that program, as was the Spitzer Space Telescope. Each one looking at a different wavelength regime and each one taking advantage of being above the atmosphere, which is why we put telescopes in space. And as discoveries piled up, it became clear that one needed to have an infrared telescope that could see finer detail, could see detail at the level of the Hubble Space Telescope, but at the longer wavelengths. And so that led to the development of the James Webb Space Telescope.
Infrared astronomy is basically centered on wavelengths that are longer than visible light. It's basically heat rays. And so trying to observe them from the ground is actually a losing proposition. We try it all the time, but the telescope's warm, so you have to fight against all the energy that's being poured out by the telescope. So the Webb telescope goes in space so it can be cooled. So it's going to be a cold infrared telescope without those big backgrounds that we have on the ground. And it's going to allow us to see very fine details because its mirror is so big. So that's why it's so exciting.
As discovered back in the 1920s, the universe is expanding. We've known for a long time that there's something called the Doppler shift, so that if something's moving away from you, the wavelengths get stretched out. If it's moving towards you, they get compressed. Stretched out means they're getting longer and redder. Compressed means bluer. So if we want to look at the most distant galaxies, which would be the first ones to form after the Big Bang, we have to account for this expansion, shifting all the wavelengths, and you get to the point where the only wavelengths that are left are ones you can observe in the infrared. So I came to the University of Arizona as a postdoc, actually hired by George. And I came here because I knew that this was where things were happening and where infrared was really going to grow.
University of Arizona is actually where infrared astronomy got started. Basically, it was founded over in the Lunar and Planetary Lab. And ever since then, the University of Arizona has led the way in infrared astronomy. We've been very involved in the very first infrared space telescope, and now, of course, we're central in providing the instruments for the James Webb Telescope.
Body health and emotional health.
George, you hired her.
Part of it is that any field of science is very intense, and you have to be very focused on what you're doing if you're going to be at the state of the art in a field of science. And so you can't really talk to anyone other than another astronomer because nobody else will understand.
Well, he hired me, and we had to spend a lot of time together. And over time, it became clear that we were not just interested in the professional work, but that we had other interests in common. And one thing led to another, and eventually we got married.
So working so closely together has the advantage that it's almost like a single brain thinking about how to do something. And it was possible to kind of intuitively understand what would be a better design and a worse design.
My role on the JWST project is as the principal investigator for the near-infrared camera, NIRCam. NIRCam was envisioned as part of the original instrument suite for the Webb telescope. And so when NASA put out what's called an announcement of opportunity to propose, George started thinking about, well, we shouldn't put all our eggs in one basket. Maybe we ought to propose for a piece of the mid-infrared instrument action. And never did we think that we would both get selected. But of course, that was history.
My instrument is the mid-infrared instrument, commonly called MIRI, and it's the instrument that lets us look inside interstellar clouds of dust where the very first stars are forming or just starting to warm up.
Well, NIRCam and MIRI complement each other because they work at two different wavelength ranges. And so if you want to do some imaging, you would need to use both instruments together. We got selected to work on the instruments in 2002, and it wasn't until about 2007, 2008 that the designs were all agreed to and people actually started building stuff. And what's going on now in August of 2021 is doing the final bits of assembly and getting ready to pack it up to ship to Kourou, which is where the telescope will be attached to the rocket.
After launch, the next big item of suspense is unfolding the solar panels, and they're batteries that last for a limited amount of time to power getting them out. The telescope is so big that there was no rocket fairing that could fit inside, so everything has to be folded up. And so there are many, many different parts that have to be articulated and extended and stretched and so on. There will be an extended period of tension because any one of those things not working would be a very big problem. And she's got to line it all up.
Right, about 35 days after launch, NIRCam will get turned on. Each of the 18 segments of the primary mirror will make an image of us, of whatever star we're pointing towards. And then as the telescope finishes getting cold, the other instruments will get turned on. And then we'll move into what's called regular science operations, where we'll start taking data, and there'll be big excitement when you see that your instrument works, and then there'll be big excitement when you finally start getting the data for your project. So you promise this wine's going to be really good?
Yeah.
Okay. As you promise.
So what are we going to do when we get our data?
See what it means and write papers.
You're going to find the first galaxies, right?
I hope so.
I think the biggest discovery that Webb's going to make is something I can't tell you. And the reason is the big discoveries are always things you don't anticipate. So it's very, very likely with this big breakthrough in what we can see and how much detail we can see and how far away we can see, that astronomers, not me, but somebody will find something just totally mind-boggling. And that's pretty much the history of astronomy. To get into space, you have to pay a big price in terms of your career and basically your whole life. The rewards are worth it, but it is a big price. So commit yourself completely to doing what you're doing, and that allows you to do it at your very best. And if you're in a marriage with somebody else that's completely committed, then there's a resonance that lets the two of you have a really big impact.
Sign up for the long haul, because you never know how much more time it's going to take. And that's a variant of being committed, but it's the same basic idea. Come on in.
Hello.
Hi.
I'm so
Really-
excited to talk to you guys.
Yeah, good to see you.
I can't wait to hear all about the exciting discoveries of this telescope. So this is a model of NIRCam.
Yes, it's one half of it.
Okay. So where does the light from the actual telescope come in on this model?
Down
It
here.
comes up here and then into the optics.
Out of those like really stunning images. Do you guys have a favorite?
I like the one that's called the Cosmic Cliffs that has the brown on the bottom and the kind of blue sky. Even though that's not my science, but it's just so pretty.
I like the pictures of galaxies with Mary, and they show tiny little carbon particles, and they get heated up by the starlight, and so you see the complicated structure of the interstellar material heated by the starlight.
I feel like they're like galaxy skeletons.
Yeah.
It's like so cool.
An image that is very mundane to look at because all you see are four little blobs. Are the distant galaxies that we discovered could prove that right now, and this won't be a record that lasts,
Yeah.
but it is the most distant galaxy we know that's been spectroscopically confirmed, so there's no question.
That's like a baby galaxy.
Discovering those kinds of objects were why this whole project was
Yeah.
started.
I know you guys have a lot of work to do, so I really appreciate you taking the time to show me the instrument and talk about some of the really incredible.
We like to brag about this stuff.
Yeah, you can come by my office anytime and we could talk about it.
I mean, after waiting 20 plus years, how could we not be enthusiastic and want to tell about what this is all good for?
For the latest updates and to view more of the spectacular images from the James Webb Space Telescope, visit webbtelescope.org. You can also follow the telescope team at NASA Webb on Facebook, Twitter, and Instagram. For our next story, I'm here at the Drake Building, which is named after a famed planetary scientist and University of Arizona professor, Michael J. Drake. It's been home to some of the university's most ambitious space projects, including the asteroid sample return mission, OSIRIS-REx. Now it's being used for a NASA-funded project to design autonomous swarms of robots that can be used to explore other worlds, like the Moon or Mars.
I was pretty dead set in working in the space and space exploration era, probably once I was about 1 or 2. That was the tail end of the Apollo program. So that's when, the first Star Wars movies came out. That's when Battlestar Galactica came out. And I have been, latched onto that ever since, really. Our lab is called Space and Terrestrial Robotics Exploration Laboratory, or SpaceTrex. And our efforts are to work on robotics for space and off-world environment, particularly focused on science exploration. And in addition, taking some of those same advancements and being able to then apply this towards challenges here on Earth. Do you guys have it go through a recalibration step? Autonomous robotics has been a key theme in developing robotic systems for space. These systems can communicate with each other, they can network, they can sort of reorganize in ways that we can't quite even imagine right now. Another more interesting area, of course, is our robots playing a key part in developing a lunar base or preparing a base. What we envision in the next 20 to 50 years or so is that we'll be going through many phases in settling the moon and setting up permanent bases there. And these early stages, we'll be setting up semi-permanent structures. So I can imagine a lunar base that is constructed entirely by a team of robots that, makes it a lot easier to live and survive in otherwise a hardy environment at the lunar surface. And they're exploring. They're exploring at a different level now compared to the Apollo astronauts, looking deep at what are resources available in their neighborhoods, looking to see if this resource is enough to, mine at large scale. And so that's been our work at SpaceTrex, advancing new space technologies to really enable new ways of exploring, low-cost ways of exploring extreme environments, and getting serious, particularly with the mining aspect, and working with the mining engineering department on this.
guys. Welcome to the SX mine. I've been talking with my colleague Jehan for some time, and what he was doing with regards to creating this swarm of robots especially appealed to me because we know kind of what is present on the surface of the moon in terms of minerals, but what's beneath the surface is still unknown. And is this metallic? Is it metal?
The rest of the chassis is metal.
Yeah. I see a lot of parallel between space mining, moon mining, and mining on the Earth. Inherently, it's a hazardous environment. It's a lot safer to send robots than people. And this is something that we strive to do on the Earth as well. So here at UA, we have a student-run mine. It used to be an operating mine, and it was donated to the university in 1950s. It provides the opportunity to test a wide range of instruments and equipment in an environment that can easily resemble the surface of the moon or other planets. We have many underground openings that we can test the rover. It's hard to send a signal through rocks or send a signal around a corner. So these rovers need to be able to make some decisions on their own, or if for whatever reason it gets stuck, then it should be able to free itself. Where my contribution is going to come in is on two fronts. One, to sense what's beneath the surface of the moon, and two, how to break the rock. We're going to use an instrument called ground-penetrating radar. So we will mount the antennas for this instrument on the rovers, and we will collect data. By thinking in the context of the moon, what's beneath the surface. Drilling uses a lot of water, so we want to be able to develop a new technology that drills without water. So I'm very hopeful and very excited that we can take this technology and mount it on one of these robots or robotic arms, and hopefully one day try it on the surface of the moon without using any water. I am certain we're going to develop technologies that it's going to benefit the society and human beings here on Earth. So for me, I think that's the reason we want to colonize the moon.
By being able to build these bases off-world, we can utilize resources off there. These resources can then be utilized to, in fact, enable and advance the next wave of space exploration. And that's what's really exciting about working at Space Treks, because that's where we are trying to, push these limits, push it to, exploring areas where we're not explored before, working with planetary scientists, and really being able to push space systems technology to enable them to ask the questions of the future.
Hey, Jehan.
Hello.
So good to see you.
Yeah.
How are you?
I'm good.
Okay, so Jehan, can you tell me about this moon base?
Yes, so this is a concept of a lunar base, and what we're visualizing here is an interaction of systems. The robots are meant to really handle all the dull, the dirty, and the dangerous tasks.
Okay.
So that the astronauts can do all the cool things.
So the robots build them before the people even arrive.
Correct.
That's the idea.
That's right.
And then there's these lights moving around. What do those represent?
These are meant to be smart lighting, and they follow the robots around, so you don't have to, in a sense, light up the entire base like a stadium.
So it's more efficient.
More efficient.
That's interesting because it's organic inspired, but also it's organic in that it's going to keep growing and evolving over the lifetime of the base.
That's right.
Okay, so you know that I want to be an astronaut. I hear you have some other things to show me, maybe some practice for the other tasks I'm going to do in space.
Fantastic, yes. We, in fact, have a on-orbit spacecraft simulator.
All right, I think we should go check it out.
So we have our on-orbit docking simulator facility, and this is a TEEP. This is a simulator that we're using to better get a handle of human capabilities in being able to dock two small spacecraft.
Okay, so when do I get to try it out?
It's right here.
All right. Okay.
So you are controlling the hexapod. You will be watching the vision target, and you're going to align the center of the ring.
All right, ready to go.
All right, start.
Ooh, ah.
The last second.
So tough at the end.
That's
It
pretty good.
almost is not going to get our dock correct.
Unfortunately, yes.
Unfortunately, our spacecraft just crashed into the space station and we all died.
Yes. Unfortunately, in aerospace engineering, almost is never good
It's
enough.
not good enough.
Wow, look at that. You got it.
All right,
Almost millimeter levels of
time to go to
precision.
space.
Yeah. Are you ready for the faster ones and the harder ones?
Okay, let's give it a try.
Let's give it a try.
Okay, reset. This has been really great. So I really like this, so I'm gonna keep playing for a couple more rounds. And thanks for coming to see this incredible demonstration of new technology with me. We're gonna rock it.
Oh, yeah.
That was also a joke.
Because it's a rock.
Yeah, exactly. Okay, we're gonna get it. You can learn more about Jahan's space robots at spacetrex.arizona.edu, and you can follow them at uSpaceTrex on Twitter and at SpaceTrex on Facebook. Thanks so much for joining us for our first episode of New Frontiers. I'm Erika Hamden, and I'm headed back to the lab. I'll see you next time. Make sure to stay tuned for future episodes where we'll explore more of the incredible innovation happening here at the University of Arizona. And if you want to know what's happening with me, follow my Instagram at Erika Hamden.